NCT of Delhi since 2008. Dr. Muralidhar Kulkarni is currently a professor in the HAG position in the Department of Electronics and Communication Engineering of prestigious National Institute of Technology, Surathkal. He is the coordinator of Center of Excellence in Wireless Sensor Networks, even at NITK Surathkal. He was a chairman, Career Development Center at NITK. He also established the IIT Dharwad to take forward IIT as an Institute of Excellence in 2015 as its officer on special duty, OSD. Dr. Kulkarni's teaching and research interests are in the areas of digital communications, 4G digital imaging, processing, optical communication and networks. He has published more than 95 research papers in the above areas in national and international journals of repute. For various contributions, his biography has been listed in the Marquis Who and Who in Science and Engineering. He has authored 6 very popular books in microwave and radar engineering, communication systems, digital signal processing, digital communications and information theory and coding. He has successfully completed several sponsored research and development projects from Department of Science and Technology, Ministry of Information and Communication Technology with a funding of around 3.5 crores. He has produced 10 PhD students and is presently guiding 3 PhDs, several BTechs and MTech students. He has delivered several technical talks and chaired technical sessions in international conferences at various engineering colleges and other forums in India and abroad. He was also a member of newly formed National Board of Accreditation, that is NBA, New Delhi at national level, and a Board of Governing Member for Malnad College of Engineering, Hassan, member of Board of Studies at University Visvesvaraya College of Engineering, Bengaluru, RV College of Engineering, MS Ramaya Institute of Technology, Bengaluru, and Siddhganga Institute of Technology, Tumkuru. He is a senior member of IEEE and member of several professional bodies such as IIT UK, IETE, CSI, and so on. We are all very pleased to have Dr. Muralidhar Kulkarni, sir. Thank you very much for accepting our invitation. Ladies and gentlemen, please welcome Professor of NITK, Surathkal, known for his positive and motivational attitude towards IoT issues, Internet on Things. His dynamic range of acquaintances and a sense of adventure are seamless. Now I wish to hand over a platform to Dr. Muralidhar Kulkarni, sir. Sir, over to you, sir, please.
Thank you very much. Nice introduction, although I don't deserve everything of whatever you have said. But anyways, I'm going to give a small talk on Internet of Things today. Start with introduction, some fundamentals, then I look at some applications. Okay. Thank you very much, Professor Prasanna Kumar, for introducing me.
Thank you very much.
I'll put off my video to get better audio quality. If you all, I'll just put off my video.
Even I too.
Yes. Can you just tell me whether my this thing is being shared or not?
Yeah, it is shared, sir. It is shared. No, not yet shared. Still, your slide presentation is not visible.
It's not visible. Okay. Just a minute. Is it visible now?
No, sir, not yet come.
How about now?
MK only, it is now it has come, appeared. Internet of Things. Yeah, that's
Internet
fine.
of Things. So I'll make it full screen. I don't know. Is it full screen now?
Not yet.
How about now?
No, not yet.
I think there is some mm, setup slideshow. Okay. Prasanna ji, is it
Sir,
visible now?
it is screen is visible, but
Mm-hmm.
as you mentioned that it is not fully covered. In fact, it is in only half of the screen. It is there.
How about now?
Only it is enlarged, but only
Hmm.
thing is still the screen size is remain same.
Yeah, I'm trying to do a slideshow, but
Full screen slides. Yeah,
how about now?
not yet appeared. Not yet.
Anyway, I'll continue with this if you don't mind.
Yeah, yeah, yeah. It's all
Yes,
right,
sir.
sir.
Yes.
Please go ahead.
Okay.
Please have it. Yeah.
Okay. A very good morning to all of you. Today, we'll talk about Internet of Things. I'll basically focus on fundamentals of IoT and some applications, which are very widely used already, and some research challenges, which you would like to look at. Okay. Uh, are you able to see the next slide?
Yeah, it has come.
I think it may not be fully visible. Uh, is it okay now?
Yeah, yeah, it is available, sir. It is visible. IoT evolution of the internet.
Yes.
Fundamentals, application challenges. Yeah.
Yeah.
Okay.
My talk would concentrate on these aspects. You'll see how internet has become IoT today, and how evolution of internet has resulted in IoT. Then we'll think of what is IoT. Then we go to a little bit of history, and we'll also check how IoT basically works. What is the current status and future prospects of IoT? Then how this knowledge management has gone from data to wisdom. That one slide of that also I'll be showing. Then we'll look at perspective and business perspective of IoT, and what is the IoT value chain. So IoT value chain is also very, very important. And we look at various technologies like RFIDs, wireless sensor networks, MANETs. Okay. COT, I'll tell you what is COT as we go along. Okay. So we'll also look at what are the things happening in R&D sector of IoT, and what is the future of IoT. How 5G IoT is going to come very soon. Yesterday itself, we have seen that 5G is going to come in 2023 in India itself, and the spectrum is being sold this year, hopefully without any scam. Okay, so potential of IoT and then few applications of IoT, and we also look at potential research challenges of IoT, and of course there are some criticisms and controversies of IoT as well. And then I give a big list of references as well. Okay, so coming to the evolution and growth of internet is highly phenomenal, as all of us know. It is basically an ongoing process. In just last 25 years, it has grown to link billions of people through computers and mobile devices. I think we are already experiencing. Okay, when you're driving your car from your home to your office, you're able to switch off the AC at home already right now. Okay, and maybe when you are at home, you can switch on the AC of your car. Okay, and then you get into the car and go to office. And after coming to office, you remember that you had not put off your light in your room. Okay, so you put off the light sitting at office. All this is possible because of IoT today already. Okay, so now the internet is being used to connect various objects such as cars, as just now I told you about cars, sensors, controllers, TVs. You can put off your TV or put on your TV, even the machinery at your home, transport containers and electrical appliances, creating what is called as the Internet of Things. In fact, Internet of Things is also called as Internet of Everything, because all devices, whatever you see in nature, including yourself, will be connected. So that is Internet of Everything. Okay, and then we also have, it's also called also Web of Things. And because this IoT is being used in industry as well, we call that as industry IoT or industry internet. Then all of us are very aware of mission to mission communication, which is actually already happening. Okay, so continuing the same thing, we know why IoT basically connects the physical world and the cyber world. Basically, IoT is the networking of physical objects, that contain electronics embedded within their architecture in order to communicate, okay, and sense interactions, amongst each other or with respect to the external environment. So in the upcoming years, IoT-based technology will offer advanced level of services and practically change the way people lead their daily lives. Just now I told you about how the things at home can be controlled sitting in your office, or how you can put on your AC in your car. Okay, the way you lead your daily lives will itself going to change significantly. In fact, we have seen advancements, which have happened in medicine area, power area, gene therapies, agriculture area, smart cities. I think all of us are aware of smart cities now, and smart homes. Just now I was talking about smart homes, are just a very few of the categorical, examples where IoT is strongly established. In fact, by the year 2022, as people are this is 2022, 100 to 120 billion things will be connected to the internet, facilitating, human to human, human to thing, and thing to thing, also called M2M communication. Okay, so this year itself, all these things are going to happen. At least in India, by next year, you will be seeing all these things happening. So in fact, IoT can collect data and automatically transmit the data, to servers or to the cloud. Okay, as I told you about COT, that's nothing but cloud of things. Okay, you can connect, you transmit all data to the servers which actually are in the cloud, where useful data analysis also can be performed. So the end game is to get, deeper insights and real time feedback, that can help you make faster and better decisions in life. So there's a huge potential for huge impact on manufacturing area, healthcare, and even public utilities and other areas. I think, your smart grid is a very good example, in which, you can sell power which you generate out of your solar panel, which you have put on top of your house. Okay, instead of taking power from the grid, you can supply power back to the grid and earn money out of it by your own solar panels which you have installed on your house top. So this is what is going to happen very soon. So IoT, basically facilitates deployment of many new applications and services, which is endless. So it has the potential to change the world, just as the internet did, a few years ago, maybe even more so. So time is ripe to look at how we can leverage and benefit, from IoT. So we can optimistically look forward to an IoT assisted world that is connected, okay, in a very smarter way and even better way, and it will be also sustainable. That's very, very important. So this IoT assisted world, okay, which will have all things connected with each other, and it is going to be much smarter, and it will keep on getting smarter and better again as time passes on, and it can be sustained as well. As I told you, we over 10 billion or even 100 billion things are going to be connected, in the near future. Already, around 10 billion things are already connected. In fact, there are four main components, which are used in IoT. One is the low power embedded systems. We are all electronics and communication engineers. So we have a lot of things to offer in the area of IoT, because, these are the four important components, which I'm trying to tell you now. So all of us know about embedded systems and how, they can be low power. So low power embedded systems is going to have, a lot of value in the job market. Okay, as teachers, we should teach low power embedded systems in a big way, how to reduce the battery life of batteries which you are producing now. So how to make, low power embedded systems becomes a very big research area to work on, and how to make it, high performance. Okay, although high performance and less battery consumption are inverse factors, they play, a very significant role during the design of electronic systems. So as electronics engineers or electronics and communication engineers, we need to look at, how low power embedded systems can be designed. So I was just talking about the cloud computing. We know that, data which is collected through IoT devices is very massive. Massive data is getting collected, because all things, keep giving you data. Okay, massive data, and this data, has to be stored on a reliable, okay, storage server. Okay, we can't have a server, which is in our campus to store this amount of data. We need, a highly reliable storage server, which is possibly on cloud. So this is where, cloud computing comes into play. So cloud computing is going to be a big research area in the years to come, and it's already, picked up. So the data will be processed and learned. We can use, deep learning techniques, artificial intelligence, giving more room for us, to discover where things like electrical faults or errors are happening within the smart grid system, etc., etc. Everything can happen on cloud. Okay. So availability of big data. So big data analytics has already taken, big steps already. We know that IoT relies heavily on sensors, especially in real time. So as these electronic devices, spread throughout every field, their usage is going to trigger a massive flux of big data. So big data analytics becomes a very important thing. Although cloud computing and big data analytics is an area of computer science engineers, we as ECE engineers can also play a very big part in these two areas. And the most important area is how come all these devices will be connected and how they can communicate, and how this internet connectivity becomes very, very important, where each physical object, will be represented by an IP address. I think, each one of us will have an IP address attached to us. Okay, how to manage so many IP addresses? So internet connectivity, which is the area of, electronics and communication engineers, becomes very, very important. How to communicate between objects. Okay. However, there are only a limited number of addresses available according to, IP naming, which we already know. So due to the growing number of devices, this naming system will may not be feasible, anymore. So therefore, researchers are looking for another alternative naming system to represent, each physical object. Although, IPv4 has come out as IPv6 already, but IPv6 addresses also may run out of the addresses, and hence, a new naming system, okay, should be looked at, an alternative naming system to represent each physical object which are there in this world. Okay, becomes a big challenge for all network engineers, whom we are already working. So this was just an introduction to how, IoT connects the physical world and the cyber world. Cyber world, when I say, it is basically the internet world. Okay, so there are two ways of, building IoT. You can actually form a separate network including only physical objects. That means, make the internet even more expansive. But this requires, hardcore technologies, such as, rigorous cloud computing and rapid big data storage, which could be really, really expensive. So in the near future, IoT has to become broader and broader, and it has to become, it is going to become more complex in terms of its scope. It will change the world in terms of, anytime, any place, anything in connectivity. So that's what I'm going to talk about in my next slide. Okay, so let us see what is this IoT all about. So my lecture actually starts now. This was all introduction. I hope, we'll have time for questions at the end of my lecture, or in between you want to stop me. Hello.
Any, any audience have got any questions to ask, sir, right now?
I have just finished the introduction on IoT. I'll
Yeah,
start with, what is IoT. Probably, we'll finish the lecture and then we can have questions. Otherwise, there
that's
will be a
better.
lot of disturbance. I think we'll continue that. I hope
Yeah.
everybody is able to hear me.
Yes, sir.
Clear? Okay, no issues. Hello, are you able
Hello.
to hear? Are you able to hear me clearly?
Yeah, your voice is audible to me, but what
Yes,
about
sir,
the other
audible.
audiences?
Yes, sir,
It
audible.
is audible. Okay. Audible.
Even the slides are visible to a certain extent, because I am not able to go full screen here for some reason. Okay. Anyway, thank you. I hope, everybody is listening. So what is
Yes.
this IoT all about? So definition of things in IoT vision is very, very wide, and it actually includes a variety of physical elements. In fact, I was just now talking about anytime, any place is going to change, for anyone into anytime, any place for anything. So this is what is going to become. So anytime, any place for anything, instead of anytime, any place for anyone, is going to change into anytime, any place for anything. So that's what, the IoT vision is all about. So definition of IoT, there are a lot of people, like Gartner, Wikipedia, and IEEE Internet of Things journal, they have defined in different ways. If you look at Gartner definition, IoT is the network of physical objects that contain, embedded technology to communicate, sense, or interact with their internal states or the external environment, is how, Gartner thought. Whereas Wikipedia defines it differently. It says, it refers to uniquely identifiable objects or things and their virtual representations in an internet-like structure. So Wikipedia gives a better definition compared to Gartner, and IEEE does even better. It explains, in what IoT is today all about. It's basically a network of networks. Okay, you remember we defined internet as network of networks. Now the same thing is talked about in IoT as well. An IoT system is a network of networks where typically a massive number of objects, things, sensors, or devices are connected through communications and information infrastructure to provide value-added services via intelligent data processing and management for different applications. Oh God, this definition of IEEE journal, includes everything. One single sentence, it tells everything about IoT. It's a massive it's a network of networks consisting of a massive number of objects or things or sensors or devices connected through communications and information infrastructure, which is nothing but the internet. And it can provide, value added services via intelligent data processing and management. So that is about cloud for different applications. For example, smart cities, smart health, smart grid, smart home, smart transportation, smart shopping. Oh God. So IEEE Internet of Things journal has defined IoT in the real way, in which IoT has to be described. So IEEE Internet of Things journal defines in a better fashion compared to Wikipedia as well as Gartner. Okay, so looking at what is IoT in slightly pictorial way, I told you about three accesses: anytime connection, any place connection, and anything connection. So we have three accesses, and each access has something to do. Say, for example, okay, so in case you want to connect between PCs, definitely it is going to be anything connection. Human to human, H2H, not using the PC is also anything connection. Human to thing, that is H2T, using generic equipment is also anything connection. Thing to thing connection, T2T. Okay, thing to thing is also anything connection. Okay, when you go to any time connection, you could be on the move, you could be outdoors or indoors, it could be night or daytime, it should not matter. Okay, you should be away from the PC or at the PC. So any place, you are able to connect. That is what is IoT all about. So anything connection, any time connection, any place connection. That means, from any time, any place, connectivity for anyone, we will now have connectivity for any everything, or that is nothing called IoE, Internet of Everything. So IoT is going to be soon Internet of Everything, which is a new dimension which people have thought. Okay, so if you look at what are these things, okay, which are the things which you are talking of, the things in the IoT or the missions in mission to mission are actually physical entities. So their identity or state, or the state of their surroundings can be relayed to an internet connected IT infrastructure. So thing can be any of the five sensors. It could be, connected to the internet, through cellular communications. Almost anything to which you can attach a sensor, probably a cow in a field, a container on a cargo vessel, or the air, the conditioning unit in your office, or a lamp post in the street, can become a node in the Internet of Things. Okay, so anybody can be a node in the Internet of Things, IoT. So what do these sensors basically do? They gather and also disseminate data, and or disseminate data. In fact, they could be, it could be location, it could be altitude, it could be velocity, it could be temperature, it could be illumination, it could be motion, it could be power, it could be humidity, it could be blood sugar, it could be air quality, it could be soil moisture. So all these things look, as if you're talking about wireless sensor networks. So all these sensors, location sensors, altitude sensors, velocity sensors, temperature sensors, illumination sensors, motion sensors, okay, humidity sensor, blood sugar sensor, air quality sensors, moisture sensor. Oh God, there are thousands of sensors, which are already available. Okay, they actually gather and, and then, disseminate data. So that is how, things in IoT are extending to anything which you can see in the world. Okay, so that is about what is internet and what is things and what is Internet of Things. Okay, so which are the if you look at history of IoT, in fact it started somewhere in 1997. Okay, in fact the Internet of Things is the seventh in the series of ITU Internet reports, originally launched in 1997 under the title Challenges to the Network. So it's not very old, 1997. Many of you might have graduated in this year. Of course, I was already, how many years? 58 means 98. I was already 40 years old when Internet of Things came into picture. In fact, it was Kevin Ashton. Many of you may not be aware. This Kevin Ashton was the guy who actually did, in 1999 in MIT, he made an auto ID center, which in which he had the IoT in place. Okay, in fact, in 2003, there was a global founded in MIT again by Kevin Ashton and his colleagues. And in 2005, 4 important technologies of the Internet of Things was proposed in the first WSIS conference. And strictly speaking, in 2008, the first international conference on Internet of Things was actually held at Zurich. So IoT is not very old. When I joined NITK Surathkal in 2008, the first international conference of Internet of Things happened. Fortunately, uh, I was an attendee of this IoT 2008 conference, okay, which was held at Zurich. Okay, I went from NITK to Zurich to attend this conference. In fact, that was the first international conference on Internet of Things. You were able to see the next slide? Hello? Any one of you?
Yes, sir. Yes, sir.
History of IoT
Sir,
Yes,
continue?
sir.
Okay, I just
Yes.
Sir,
wanted to take. I
Muralidhar
wanted.
Kulkarni, sir, please
Huh?
do one small this one. Press the shift plus F5 for the full screen.
Yeah, I am doing it, but
Press
still
the
it's not.
shift plus F5. Yeah,
I have done it, but it is not coming.
yeah. Okay, it's fine. Okay, that's fine.
Is it
It is
coming?
audible.
I tried all the methods.
Okay, okay, that's fine.
Okay, sir.
Let me try, once again from the current slide. Now is it visible?
The same
Yes,
previous
sir.
state only. It is
Hmm?
visible. It is visible.
But not full
It
screen,
is
right?
visible. Not full screen. Okay, it's not taking. Okay, fine.
Sir, current slides. Sir, from current slides, so you can press, sir. You
Yeah,
may
that's
be
what.
press, sir,
Yeah, I have done
from
that.
current slide.
Is it full screen now?
No, sir.
No. I think I have failed in all possible ways.
Okay, it's
Same
fine,
thing
sir.
Okay.
Please.
happened. Same thing generally doesn't happen in my regular classes. I don't know why it is not taking here.
Okay.
I don't know. Setup slideshow. There is one more icon here. Let me check. Browsed by an individual. Browsed at a kiosk. Okay, using timings. Oh God. Mhm. It's not happening. I'm sorry. I think all of you must be sitting on your mobiles. You must be able to see, if it is possible. Anyway, I'm sorry. I took some rest in between. I was talking continuously. Okay, we'll continue with the history of IoT. As I told you, it was proposed in 1999 through an auto ID center at MIT by Ashton. And the IoT enablers were basically, RFIDs. In fact, initially, it came out as an RFID, okay, which actually uses, radio waves in order to electronically track the tags, attached to each physical object. I hope you know RFIDs. Okay, it is almost a prerequisite for IoT at that point of time. Now, no more. Okay. In fact, the other enablers, IoT enablers, were the sensors along with RFIDs. As I told you, sensors, are devices that are able to detect changes in an environment like motion detectors, etc. And the third enabler was, nanotechnology. If you remember, as the name itself suggests, these are extremely small devices with dimensions, usually less than 100 nanometers. That's why it's called as nanotechnology, and then smart networks. So basically, during that time, it was the RFIDs, the sensors, the nanotechnology had just then started, and then smart networks using mesh topology was happening during the early 2000s. Okay, so if all objects and people in daily life were equipped with identifiers, they could still be managed. So besides using RFID, the tagging of things may be achieved through such technologies as near field communications. I think many of us are working on near field communication research area. We are very fond of barcodes. Okay, QR codes, day in and day out, we are using them. So Bluetooth, all of us know, and digital watermarking. Okay, already in image processing, a lot of people are using this. So right from 1990s, where internet was being connected, communication was possible between satellite to satellite, satellite to ground, satellite to airplane, etc. And around 2000s, you had a massive mobile communications using cellular towers and vehicles, moving around, or mobile objects. Okay, then utility meters also came in the early 2000s, and home alarms. And in 2010s, we had watches, which had a lot of sensors. Okay, wireless access points, Wi-Fi came into picture, and even the TVs, the refrigerators, everything under the within the home were actually connected by one or the other technologies like Bluetooth and and other such things. So what I mean to say is, IoT started in a very small way from RFID. It went on to NFC, barcodes, QR codes, Bluetooth, digital watermarking, okay, connecting devices within the house as a smart home, and then making the grid smart, etc., etc. That's how things started. So if you look at the history of IoT in a pictorial way, so initially, you had a network which was, connecting only computers, if you remember. Okay. And then, the internet came into picture, wherein I had a world wide web where several hosts were connected to the web. Okay. And that became the internet. So from a normal computer to computer network, we evolved into the internet. And from there, the mobile devices started getting connected themselves to the internet. So the World Wide Web, we were able to connect it to the mobile devices as well, along with the host, the computers. Okay, and from mobile internet, we came to mobiles plus people plus PCs. Even the people started, getting connected themselves, either through mobile or otherwise, into the World Wide Web. So from mobiles plus people plus PCs, now we have come to IoT, wherein everything, whether it is house or a refrigerator or a car or a mobile or people or any kiosk, anything under the sun will get connected. So interconnected objects. Earlier, interconnected people, interconnected mobiles, interconnected PCs. Okay, up to 2010. After 2010, it was basically interconnected objects. So technology advances, are expanding even the boundaries of the internet. So device processing power, storage capacity are increasing, while the technology is making devices, smaller and smaller through nanotechnology. So devices are increasingly fitted with sensors and actuators. Okay, all of us know about actuators and sensors being embedded. Okay, and being fitted, in almost every device. Okay. So if you look at the influence or the structure of IoT, so it is basically the people. So more things can be monitored and controlled. So people will become more capable. So what are the advantages? What is the influence which IoT has on us? And what is the structure of IoT? So these two things in the same slide. So people, will become more capable, and more complex tasks can be accomplished in lesser time, because, more users, more missions will collaborate in real time. So the process time will be reduced, and hence, complex tasks can be achieved even by giving, audio commands. Okay, and things will become more controllable. So mobile devices and things become more valuable, more valuable. Suraj, I am in a class. I'm sorry, my son called me from Canada. I'm sorry for this. Thank you. So I was talking about, how people process data and things, okay, become, more and more connectivity will be better, processing speed will be higher, and a lot of data can be connected better decisions can be made, okay, and there will be a lot of value in whatever we do. So in a 2005 report, ITU suggested that ITU will connect the world's objects in both a sensory and intelligent manner. Okay, so based on this, there are 4 dimensions of IoT. One is called item identification. That is, we call it as tagging of things. Then the next is sensors and wireless sensor networks. So we should be able to feel things. So tagging things, feeling things. Then we should have embedded systems which will also be able to think. So you should be able to tag, feel, and think as well. And then, I was talking about nanotechnology, shrinking things. So all these things become very, very important. Okay, all these things become very, very important. So IoT can be viewed as a gigantic network consisting of networks of devices and computers connected through a series of intermediate technologies, where numerous technologies like RFIDs, wireless connections may act as enablers of this connectivity. So this is the latest definition of IoT. I was talking about tagging things, real-time item traceability and addressability, probably by using RFIDs, and feeling things can happen because of sensors, which act as primary devices to collect data from the environment. Shrinking things, as I told you, it's miniaturization or nanotechnology, ability of smaller things to interact and connect within the things are smart devices. And thinking things are basically, embedded intelligence. We have to embed intelligence into the things or into the devices through sensors, which has formed the network connection to the internet. So these 4 important things become very, very important. Okay, so going to the next slide, let us see, how IoT basically works. IoT is not the result of a single novel technology. In fact, several technologies are combined together. Okay, complementary technical developments provide, capabilities that taken together help to bridge the gap between virtual and physical world. So IoT, is not a single novel technology. In fact, many people, all of us have to join together to make it possible. So these capabilities can be these various areas. So communication and cooperation, E&C people have to do it. Addressability, again, E&C people. Network, everything has to be given IP address. Identification and sensing, again, electronics people. Actuation, mechanical, electromechanical, sensing and sensing, actuation, and identification, is the job of electrical and mechanical engineers. Embedded information processing, again, ECE engineers. Localization, user interfaces, probably by CSE engineers. So anyway, all of this will require, some kind of programming, some kind of device knowledge, some kind of, data processing, some kind of, AI, which can be introduced everywhere. AI or, machine learning, to make it, intelligent information processing. We have to use AI or ML techniques to do all these capabilities which are required for making, IoT work. We should be able to massively scale it, and it should be as efficient as possible. Okay, and we must design devices, which will consume very less power. Okay, and they should be automatically programmed to sleep, to save power. Okay, and any instant of time, you should be able to wake it up, and intermittent connectivity should be possible, because the bandwidth of the internet can be used most effectively. Okay, and as I told you, IP based addressing may not be suitable in the nearing future. Okay, so bandwidth has to be properly utilized, battery consumption has to be reduced. Okay, we should be able to power off, periodically when not in use. Otherwise, connections might turn, unreliable, and they may become inefficient. That means, IoT, when it incorporates, some trillions of devices, sensors, billions of smart systems, millions of applications. Okay, then, all of us, engineers have to work very hard to make it possible. Okay, in fact, more than 60% of E&C and CS engineers, okay, are doing the research in IoT area, whether they like it or not. Okay, for example, if you look at the application domain of IoT, the industrial and manufacturing businesses, possibly will use 40% of IoT. So 40% of IoT business is in manufacturing and industrial business, and around 30%, okay, healthcare. So healthcare is going in a big way to use IoT advantages, and security also. So security of everything is around 8 to 10%, and retail businesses, around 10%. So all these percentages, I'm just giving you an idea as to how important, okay, IoT research would be, and how, in which businesses, in which application domains, IoT becomes very, very important. I told you the manufacturing industry, and wherever, big industries are involved, okay, that will constitute around 40%. So the next 60% will be between healthcare, security, and retail business. Okay, and you know that, you have seen several modern applications, as I told you about smart grid and how energy can be saved, and we are talking about smart cities, where, even if you're speeding slightly more than say 100 kilometers, where the speeds are 80, you will immediately get a notice at home to pay 1,000 rupees, is it not? So that is smart city all about. Okay, smart homes, okay, healthcare, earthquake detection, or tsunami detection. So in fact, some radiation could be happening, radiation detection, hazardous gas detection. In fact, we should be able to detect a smartphone also. If some terrorists are using smartphones, we should be able to detect where they are. And if water is getting wasted in Bangalore, water becomes in another 10 years there will be no water to drink at Bangalore city. So water flow monitoring and water wastage monitoring becomes very, very important in cities like Delhi and Bangalore. And traffic monitoring, as I told you, very, very important. And all variables, whatever watch you are wearing, it's able to tell everything about what your physical, your health parameters, can be easily monitored by using, a wearable watch, okay. So all these things become possible, because of the research which is happening in IoT. Okay, we'll go to applications, as we progress. So how IoT basically works. Okay, so we have to identify and track the data of things by means of, say, RFID tags, and then, sensors collect and process the data to detect the changes in the physical status of things. And then, we use smart technology to enhance the power of the network by devolving, processing capabilities to different parts of the network, and then, nanotechnology to make the things smaller and smaller, which will have the ability to connect and interact as well. So this is how, IoT basically works. IoT basically works. So if you look at business perspective of IoT, okay, the driver of all this connectivity is essentially the desire to add value to the products or services. So for example, $100 handset turns to a $600 smart device, which is connected to the internet. I think all of us are using iPhones now. So why iPhones are the most uh, widely, the whole world, iPhones are the largest phones sold, because, they have become more smarter and smarter, and hence, much more expensive than, Android phones. Okay. Now I'm just talking about iPhones, their capabilities, how a $100 handset will become, $600 or even higher. Okay. So the Cisco has made a study saying that, the business additional profit, okay, will be out of IoT only. That's what it says. 14.4 trillions net profit for the coming 2 decades will come from IoT. So potential of using the internet is 50%, and businesses additional profit will be, $613 billion. So Cisco has made a study, and hence they are in the networking business. They know that they can make a lot of money in networking, because, all devices are going, all things are going to get connected to the internet, to the network, and hence, they'll be able to make, hell lot of money later on. So that is the business perspective of IoT. And if you look at the current status and the future of IoT, earlier, around the population of the world was 6.3 billion. Around 500 million devices were connected in somewhere in 2003, and in 2010 the world population increased to just 6.8 billion, whereas the devices connected became 400 million to 12.5 billion, and this increased to 7.2 in 2015 and to 7.6 billion in 2020. Okay, but the connected devices kept on increasing from 12.5 billion to 25 billion and now to 50 billion. Now in late 20s, it's going to be 100 billion devices going to be connected in early 2020s itself. So the connected devices per person will be around 7 in 2020. So it's going to be much higher. So change is the only thing which is permanent in this world. I keep telling in my classes that if at all you want to be here in this world, you have to keep changing. Change is the only thing which is permanent in this world. So all connected devices per person, which was 0.08 in 2003, has become around 7. Okay, in 2020, and by 2030 this is going to be something like 20. That's what I'm looking at. So I was talking about IoT as a network of networks. I told you, how IPv6, okay, has increased the number of internet addresses, which is able to process, and analyze huge volumes of data. But I told you it may not be enough. You have to look at different naming possibilities. So internet applications using IPv6 would be able to communicate with devices attached to virtually all human-made objects because of the extremely large address space. So it's a 128-bit address. All of us know IPv6 protocol. So according to Cisco, there are potentially 1.5 trillion things that could be connected to the internet, equivalent to about 200 connectable things per person in the world today. So 200 connectable things per person. It's talking of 20. Now it has become 200. That's what Cisco says. So these networks, connected with added security, analytics, and management capabilities, this will allow IoT to become even more powerful in helping people achieve complex tasks. So looking at Internet of Things, the education sector, transport sector, energy sector, business, all businesses, home sector, smart homes, earth entire, and other things. Okay, all of them has to manage, you have to manage individual networks. We should be able to connect together with security, analytics, and management. So these are the three important things, which IoT has to look at. So this is where research is going to be. So you should look at individual networks. When they are connected together, different protocols may be required, different devices may be required, different sensors may be required, and security will become a big problem. Big data analytics will become very important, and how to manage all the devices, connected to the internet is again, we have to look at so many things, entire thing. Okay, entire thing. Okay, will have to be looked at. Will have to be looked at. So I was talking about, knowledge management. I was talking about knowledge management. So how to turn data into wisdom, very, very important. Okay, if you look at this uh, figure, you can see wisdom on the top of the triangle. So data is at the bottom, but very, very, very less important. Data is less important now. Okay, all this data is available on the net. I have taken straight away from internet without actually, giving references in every slide. I have given it at the end. Okay, so data is useless. Data is useless. Okay, the more data that is created, the better understanding and wisdom people can obtain. We have data, we have information also now, answers to who, what, where, when, all these questions, if at all you want answers to them, it is possible in the internet today. You don't have to ask the teacher. So professors will become useless in a few years to come. So knowledge is basically, answers to how questions. Okay, that, possibly all teachers, all of us are teachers, we are able, if anybody asks you how this works, maybe you should be able to tell. That is what is knowledge now. Okay, so understanding, that means, why it is happening, many of us may not know. How it is happening, we know. Where it is happening, when it is happening, how it is happening, okay, is all possible. Why it is happening could be a bigger question, which many of us may not be comfortable with, particularly as teachers or students, whatever it is. But to evaluate the understanding, first is understanding, and to evaluate that understanding is wisdom. So benefit to humanity will come when very less important data, information, knowledge becomes understanding. We should be able to appreciate, why things are happening like this. And most important is the wisdom. Okay, how to evaluate that understanding, that is what is life all about. So knowledge management becomes more and more important. So evaluating whatever you have understood, appreciation of why, how, who, what, where, when, okay, all of which is available on the net today. Okay, unless you evaluate that understanding and live a better life, okay, that is what is knowledge management all about. Knowledge management is nothing but turning data into wisdom, turning data into wisdom. Okay, so looking at the IoT communications and some perspective, so we know that local area networks have already gone wireless, okay, through Wi-Fi now. Earlier you had a wired networks, we had NFC and RFID to a certain extent. So Bluetooth also we had, okay. We have XB, Zigbee devices, Zigbee networks, Z-Wave, wireless M-Bus, etc. Then wired links have become very old now. Ethernet, home plug. I think all of us know about home plugs, home PNA, home grid, loan networks, etc. When it goes to wide area, we are using GSM and GPRS, 3G, LTE, 4G, 5G, 6G, or even WiMAX. Okay, so IoT communications is basically related to all these technologies. So why I put these two, local area and wide area networks, is that we are all going wireless. Okay, so and we're all going mobile. So if at all you ask me, what area to work on mobile communications, work on wireless networks, work on, security in these aspects. That's what, 5G and 6G is doing all about. Okay, so 5G networks are going to be, really real-time communications, real-time internet, okay, with latencies less than a millisecond, and gigabits of information being transferred. So data rates of the order of 100 gigabits is what people are looking at when you talk of 5G or 6G. Okay, so this is about IoT communications. As communication engineers, I thought we should look at local area networks, wide area networks, wireless networks mostly, not wired. Okay, and we should look at 6G networks, 5G and 6G networks. Okay, WiMAX has already gone. Okay, it's no more relevant now. So it's mostly going to be 5G or 6G networks. So basically, the IoT acceleration happens due to microcontroller, how to reduce the price and increase the performance and reduce the price of microcontrollers, how to make better sensors, how to make the cloud have better infrastructure and higher level of applications, AI based cloud based applications. So mostly it's applications development on cloud, and wireless connectivity, how less you can price it. So that is how IoT can be accelerated. So if you look at humans and devices, I already told you in 2020, okay, around 7.6 billion humans are going to be are there already, and around 50 billion people are 50 billion devices are already connected. And how from 1995 it was almost zero. In 2003 it started going up, and in 2020 and beyond, okay, around 50 billion devices are going to be connected. So earlier it was human to human communication. Now it has become internet connection. So this is the internet connection increasing, and human to human communication is below below 10,000. That means we don't talk to each other anymore now. Even within the house, from room to room, you would be possibly talking over your mobile. Okay, or if you talk in your room, other fellow, if you have his IP address, you'll be able to talk to only him. Okay, so human to human communication has almost become a non-existent today. Okay, non-existent today. So if you look at typical characteristics of IoT nodes, okay, as I was telling you about how this ARM processors working at tens of megahertz. Okay, so still limited processing capacity is there in our ARM 7 or even ARM 10 processors. Okay, they have very small memory capacity. 4K or 8K bytes may actually go up to 256 only. And although we call them as low power, generally they are battery operated. Most of the times CPU will be sleep mode. RF unit often have a current draw of over 10 to 30 milliamperes, and the range is pretty low, a range of around 10 meters. Okay, can reach over 100 meters in line of sight. That means I'm talking of the IoT nodes. So present day IoT nodes have limited processing, smaller memory. Although they operate in low power, still it has to be reduced. They have lesser ranges of the order of 10 to 100 meters, and they operate at very low bit rates. So maximum over the air rate of 250K bits per second. In practice, few by bytes per minute or even per hour. Okay, so this is the problem, which the IoT nodes of present day are facing. So how to increase the processing capability, how to increase the memory capability, how to make it lesser power, how to increase the range, how to increase the data rate, okay, is the challenge, which you have to look at when you design an IoT node. Okay, so if you look at the system architecture and components, okay, it has to be simple, it has to be secured, and it has to be scalable two-way connectivity. So in one simple 2-3 words, simple, secured, and scalable, 3 S's, two-way connectivity is what is required, okay, for IoT architecture. So designing reusability and scalability becomes the key. Okay, you can see here low power, low range, low rate connectivity. Okay, you can see this all dotted things are low range, low rate, low power connectivity. So you can have several wireless devices being connected. Okay, low power devices. We have an edge router. So this is the backhaul, which could be still low data rate connectivity. So this is called the edge router or edge computing, as you know already. And this is the actual internet. So the management system is actually the internet. So the end user applications will be somewhere here. So this is how the various devices of IoT architecture will look like. Okay, if you look at the real network kind of architecture of IoT, okay, we have some 5 layers here. Okay, strictly speaking, we have only 2 layers in IoT, but they have been extended to 3 more layers which are in the internet. So the perception layer is basically the layer which pursues data from the environment. That means there will be a lot of sensors here, okay, barcodes, RFID tags, GPS, camera, etc. So that we call it as a perception layer. So how networking is changing from that 7-layer model to TCP/IP, okay, and now we call of IoT layers. IoT layers are totally named differently. One is called the perception layer, okay, which will perceive data from the environment. Then we have the network layer, okay, which actually collects the data from the lower perception layer and sends it to the internet. And the network management center or information processing center could possibly be here, or it can go itself to the internet management layer itself. So the internet layers are having 3 layers: middleware layer, application layer, and business layer. So middleware layer basically looks at service management, storage of data, information processing. It takes decisions automatically based on the results, whatever network layer data it has given. So it will correlate all the data, stores it, gives the services required by the real user. So the application layer, as you know, is the final presentation of data. So it looks at the global management of the application based on information processed by the middle layer. And the business layer, okay, is nothing but making money. Okay, so business layer is all about, like I was talking about Cisco, how it's going to make hell lot of money once IoT, the big IoT is in place. Okay, making money based on what services you provide. So data received at the application layer is molded into a meaningful service here. So that is what is the business layer all about. So this is the network layer architecture of IoT. Network layer architecture of IoT. So if you look at pictorial representations, so the bottom layers will consist of sensors and connectivity to the network. Then we will have the gateway. Okay, we have the gateways here. Okay, then the management service. Okay, device modeling, configuration and management, data flow management, all these things happen in the management service. And the application layer. Okay, so we have the sensor network here. WSN is basically here. Okay, sensors, actuators, tags, the entire WSN is going to be in this part. Next layer would be your GSM network or 4G or 5G network. You may have Wi-Fi and Ethernet, the gateway control, and then it comes to the management, and then the real application. It could be energy application, environmental application, healthcare, transportation, people tracking, retail, supply chain management, surveillance. So these are the various applications which you can think of. Okay, in these 4 important layers of IoT. So I was talking about the IoT value chain. Okay, so radios, basically chips that provide connectivity based on various radio protocols. The sensors, chips that can measure various environments. Then microcontrollers, processor storage that allow low-cost intelligence on a chip. Then we have modules. We can combine radios, sensors, microcontrollers on a single package. Okay, that is what is the IoT node I was talking about. So IoT node basically will have radios, sensors, and microcontrollers in a single chip. Okay, SoC, system on chip. Okay, then the platform software that activates, monitors, and analyzes the device network. Then I'll have application software that presents the information in usable and analyzable format for the end user, and the device which integrates modules into application software into usual form factor, airtime, use of licensed or unlicensed. So this is money making business. Service, deploying, managing, supporting IoT solution, which Cisco is trying to do. So this was the research done by Raymond James, okay, long ago. It's a very old slide. Okay, so the future of IoT will be something like this. So you'll have, virtually, okay, around 50 billion missions or things being connected, okay, with the real-time network planning, shipment visibility, so supply chain, so brilliant rail yard, brilliant hospital, brilliant power management, that is smart grid. Okay, so hospital optimization, intelligent medical devices, connected missions, so brilliant hospital, brilliant rail yard or shipyard, whatever you can call. Okay, then factory optimization. Okay, how to make things work optimally. Then logistic optimization. Okay, brilliant factory. So we are looking at brilliant rail yard, brilliant hospital, brilliant power, and brilliant execute ಮಾಡಿ ಪರವಾಗಿಲ್ಲ. Brilliant factory as well. That means sky is not the limit. It's only the beginning with IoT. So people say, whenever they say sky is the limit, I'm telling you, sky is not the limit at all. It is only the beginning when it comes to IoT. Okay, so the potential of IoT, as I told you, in aviation industry, it's $30 billion. Even if 1% fuel saving, if you can do by using, industrial internet, okay, connecting around 150 billion in waste across industries. Okay, you can eliminate connected missions and data could eliminate up to $150 billion in waste across industries. In aviation, 1% fuel savings, 30 billion. 1% fuel savings in power sector, $66 billion. In healthcare, system-wide, 1% reduction in system efficiency. You see how inefficient our healthcare system is. We can actually save something like $63 billion. In rail, freight reduction, 1% reduction, system inefficiency, $27 billion. In oil and gas, 1% reduction in capital expenditure, $90 billion can be saved. So this is the GE's estimate on potential of just 1% savings applied using IoT across global sector in global industry sectors. Oh, this is the kind of savings which you will get by using IoT to its best usage. Okay, so unlock the massive potential of IoT is the one sentence: by improving performance, by creating innovative services, by reducing costs, and new revenue stream automatically happens. So you should unlock the massive potential which IoT has. Okay, so this is the technology roadmap. I was talking about how in 2020 and beyond. Okay, how the physical, there will be a physical world web. You have heard of World Wide Web, right? WWW. That will become PWW, physical world web. That means all physical things will get connected. Okay, so you can see how teleoperation and telepresence, ability to monitor and control distant objects. Okay, locating people and everyday objects, surveillance and security. I'm going backwards. So initially it was RFID tags for facilitating routing, inventory and loss prevention. Then came supply chain helpers, surveillance, security, healthcare, transport, food safety, document management. Then locating people and everyday objects, so vertical market applications. Then ubiquitous computing, ubiquitous positioning happened, okay, by teleoperation and telepresence, ability to monitor and control distant objects. And later on, the entire, there will be a world wide web with software agents and advanced sensor fusion is going to happen in the years to come. So that is the technology roadmap which people are thinking of. So I was talking about, the applications of IoT. I don't know how much time I have. Professor Prasanna, how much time I have? If Prasanna is around.
Until 11:15 you have, sir.
Oh, I have enough time now. Okay, okay. I have around
Yeah,
54 slides. I'm still in
yeah.
slide number 29. I think I'll be able to cover. Okay, thank you. I just wanted to take some
Thank you,
rest in
sir.
between.
Yeah,
Thank you.
certainly.
Yeah. So we now look at applications of IoT. Okay. So I was talking about healthcare. Okay, healthcare becomes very very important. Okay, we have to bring technology closer to the people. So applications of IoT are necessarily to bring the technology to the people. So that is where IoT becomes very very important. Okay, so if you look at healthcare, we know that patient care in hospitals is horrible. How it can be improved in ICU, you hardly see people being helped. There'll be one sister for something like 20 25 patients. It is not possible at all. At home it is horrible. You don't have any health care at home at all. So can I have an ICU at home? ICU in hospitals is there, very very bad. Patient care is very bad. So that has to be, IoT is going to help you there. So teleassistance for aging and rural citizens, that's very very important. If you grow old and if you meet with heart attack when you are taking a walk in the morning, okay, in the park, okay, you should be helped immediately. So for aging and rural citizens, okay, teleassistance becomes very very important. So connected home, we already talked about connected home. Okay, how home safety, suppose if some uh, both husband and wife work now and children also work, so nobody is at home. So your home can be easily it's a highly unsafe place in the world. Okay, so but with IoT, you can have sensors all over. You can check what is happening at home. You, even when you are in office, there will be alarms that your house is being okay taken for a ride. So security of your house, safety of your house, automation and control, smart appliances, home entertainment systems, all that is possible if you have a connected home. Then telematics. Okay, so improvement of safety of transporting systems, fleet management and traffic flow optimization. Okay, so this becomes very very important. That is a major thing of smart cities. In fact, Asin and Gascon have said that there are at least 54 application domains under 12 categories. Okay, Asin and Gascon have made a study. There are totally 54 application domains under these 12 categories. Okay, you can see smart cities, smart environment, smart water metering, security and emergencies, retail, logistics and industrial control, smart agriculture, smart animal farming, domestic and home automation, and e-health. So these 12 categories are going to increase further, and this 54 is going to become much more. Okay, and just talking about these only in these black areas which I am showing. So safety and security, periodic monitoring of the architecture status, okay, emergency warning information is all possible. So the ultimate goal of IoT is to automate human life. How to automate human life is the ultimate goal. Okay, so looking at other applications, I was talking about smart grid, where it enables smooth and efficient delivery of electricity. Okay, so you have an automatic metering systems. Okay, green energy integration and energy management. It actually saves energy, reduces cost, and increases reliability. Okay, and we already talked about smart home applications equipped with innovative M2M connectivity will open up a new era in convenient, efficient home management and quality of life. This already has happened. Smart home appliances are already happened. Smart refrigerator, if you look at, okay, how you can actually manage the food, which you have actually prepared, okay, today, and you can check, it allows consumers to check food items stored inside the fridge for information such as location and expiry dates of items which you have stored in your fridge via their smartphones or its built-in LCD panel. I can have a smart refrigerator which will have a LCD panel. It will tell you what all things are there inside the refrigerator, what is the last date, expiry date of each one of them. Okay, and appliance, even recommends dishes that can be cooked using the ingredients it happens to be storing. In fact, you don't require anything. Just have a smart refrigerator. It will manage your kitchen completely. So that is what is a smart refrigerator. So these home appliances, are very, very interesting. So IoT application immediately visible in smart home appliances and smart refrigerators. So if you look at industrial monitoring, if we can increase the productivity, efficiency, and safety. We can do mission surveillance. We can asset tracking and storage monitoring as well. Okay. Everything within the industry. So industry IoT, I told you it's around 40% of IoT budget. So agriculture monitoring, I think this we have been doing as part of WSN. So it now becomes part of Internet of Things. So accurate temporal and spatial monitoring of agricultural fields is possible. We can reduce the water requirement. No water will be wasted. Okay, energy also can be saved, and pesticide usage. You can reduce the amount of pesticides which is being used in your agriculture, okay, by using proper WSN or proper IoT, so we can have better productivity. Okay, so we have to have IoT in a big way in agriculture, particularly in India. So smart cities are already in place. So sustainable urban development, eco-friendly infrastructure, water management, land management, skills and energy resource optimization. So that is what is going to be a smart city. So what I mean to say is, you name it and you will have it in IoT. You name any application you can think of, okay, we can make it part of IoT. You can make it part of IoT. So for the industrial internet, I was talking about 40% of the entire budget will be in the industrial internet or industrial IoT. Okay, so I told you about the power of 1%. Oh, I think this I have already talked about. Okay, how in aviation, power, healthcare, rail, oil and gas. Okay, how we will be able to save so much. Billions of dollars can be saved by using 1% savings. So the power of 1% is already visible in these industrial areas. Okay, so I'm just giving you how smart parking, all this is taken from internet. Okay, so we can create something like $41 billion by providing visibility into the availability of parking spaces across the city. You can see how the cars have been parked here. Okay, so you have automated cars. Okay, you just at the entrance you leave your car. Okay, it automatically goes itself and sits in a place most efficiently, and when you come, the car will automatically come back to you, and you can just pick it up and go. So residents can identify and reserve the closest available space. Traffic wardens can identify non-compliant usage, and municipalities can introduce demand-based pricing. Okay, so you can keep charging based on the demand. Okay, so it can $41 billion budget. I mean, the business is possible by introducing smart parking in any city for that matter. Okay, so efficient waste management. So smart city goes in a big way. In Bangalore, they are doing it horribly bad. I was in Bangalore last week. Okay, you don't have proper bins in front of the houses. Okay, the wastage is not properly segregated, and if you look at the vehicles being used to take the waste from house, okay, they actually spread waste all over the place and make Bangalore look horrible. So how to make efficient waste management? Okay, Bangalore is not at all a smart city. It's one of the worst cities I have ever seen. Okay, so IoT can definitely help. Okay, Bangalore become a better place. If you go to US, they have already done it at least a decade back, how to collect waste from every house. Okay, the fellow who's sitting in the vehicle, he's all alone, only the driver. Okay, there are automated systems which will take your bins, okay, and put it into the truck, and the trucks will be closed, unlike in our cities where the waste is put openly, and it will keep spreading all over the road. Nothing of that sort. Okay, the fellow comes, stands for a minute in front of every house. Okay, he operates sitting within the truck itself. Okay, automatically the bins are picked up and put in the proper bin within the truck. Okay, so that's a smart truck. Okay, garbage trucks as data collections. I have seen this happening in US 5 years back. I don't know, maybe they have improved even further. Okay, infrastructure with access to energy sources and long range data communication is the requirements. We require better garbage cans with low cost passive sensors. So there will be sensors here, and they can be put into the truck automatically. The fellow need not come out also. Okay, and the garbage truck should be actually closed, unlike in our places. So the garbage cans with active sensors, okay, and there is a cloud platform that supports sensing as a service. Okay, he knows whether he has covered all the okay, he has a system in place where he knows that all these houses in this area have been covered and they can be managed. Okay, so there is a city council, a recycling plant, a manufacturing plant, a health and safety authorities. So based on that, the cloud will be used for doing all this. So that is a real smart city. This has happened a decade back in US, and in India, it is still to happen. Okay, so efficient waste management in smart cities is a must. So it should be supported by the sensing as a service, SaaS. Okay, we have SaaS in a different way. Here, sensing as a service becomes a new terminology. Okay, so this is another way as to how everything gets connected. Okay, so this was in 2015. Imagine residential electric consumption by end use 15%. So air conditioning 17%, space heating 15%, water heating 14%, refrigerator 7%, elsewhere classified as 13%, new end users, TVs and related things 7%, lighting only 10%. So all this has been studied as part of a smart grid project in LA, Los Angeles. And you know who has done it? University of Southern California has a research group, okay, which actually has designed the smart watering systems and smart grid systems. Okay, it is part of a group of research scholars and professors who designed a smart grid and a smart water management system. Okay, in Los Angeles, in University of Southern California. I have attended that presentation by University of Southern California PhD students, where they explained to the water resources department and electricity department of Los Angeles, and they were so happy with the kind of work which university people had done. Okay, and that is a dream in Indian universities. Okay, so they have integrated the electricity, the houses. Okay, and they have cloud management system. Okay, and the entire smart grid has been managed 10 years back. I visited somewhere in 2013, and 7-8 years back, they already had a system in place. Okay, in Los Angeles. So I have told you about sensors can be there even in the cow. Okay, in the world of IoT, even the cows will be connected and monitored. Sensors are implanted in the ears of the cattle. This allows farmers to monitor cows' health and track their movements as well, ensuring a healthier, more plentiful supply of milk. At least this, in India, it can be easily done. It can be easily done. Okay, so this must be done. Okay, because we have a lot of cows in our country, and cow management becomes very, very important. Their health is very important. Okay, and we are the largest consumers of milk, and you have seen now Amul revolution. Okay, so that will come even better, by putting a lot of sensors on each of these cows. Okay, so we know nothing remains static, especially when it comes to the internet. Initiatives and advances such as Cisco Planetary Skin, GE's Industrial Internet, HP's Central Nervous System for Earth, it's called SENSE, and Smart Dust having the potential to add millions, even billions of sensors to the internet. So you can see, big companies working on IoT, Cisco, GE, HP, okay, all these big companies are working for IoT. Can you believe? So as cows, water pipes, people, and even shoes, trees, animals become connected to IoT, the world has a potential to become a better place, hopefully. So that's a big question mark. Okay, with the trillions of sensors embedded in the environment, all connected by computing systems, software, and services, it will be possible to hear the heartbeat of the earth, impacting human interaction with the globe as profoundly as the internet has revolutionized communication. That is what a HP lab researcher tells, with the trillions of sensors embedded in the environment, all connected by computing systems, software, and services, it will be possible to hear the heartbeat of the earth, impacting human interaction with the globe as profoundly as the internet has revolutionized communications. That's what Peter Hartwell a senior researcher at HP Labs tells. Okay, how much more IoT can do is only left to your imagination. Okay, so why I chose the topic of IoT is because this is what is going to be the future. Okay, whatever you imagine should be part of IoT, should be part of IoT. So that means IoT is the next stage of information revolution with the interconnectivity of almost everything. So integration with internet implies that devices will use an IP address as a unique identifier, and objects in the IoT will have to use IPv6 to accommodate the extremely large address space required. I told you IPv6 is not enough. Okay, we have to look at different naming systems. So objects in the IoT will not only be devices with sensory capabilities, but also provide actuation capabilities. We have to use some kind of MEMS. Okay, mechanical electro, what is this? Micro electromechanical sensor. What is this MEMS? Hello, anybody can prompt? Hello, MEMS devices. Optical MEMS are also there. What are MEMS?
Micro electrical mechanical systems.
Mechanical systems. So there is basically, objects which have sensory capabilities and also provide actuation capabilities. So that's what is MEMS all about. And IASC is doing, a lot of research in this area. They are doing something called optical MEMS. On the other hand, IoT systems could also be responsible for performing actions, not just sensing of things. That means, these actuators are basically trying to do some action. So that is what is IoT going to be in the coming years. Okay, so as I told you, in IoT application scenario, shopping is very, very important. When you want to shop in the market, the goods will start introducing themselves. When entering the door, the scanners will identify the tags on your clothing. And when you are paying for the goods, the microchip of the credit card will communicate with the reader. This already is happening. Just have to show a credit card, okay, whatever you have purchased, whatever amount, it it will go from your credit card. When moving the goods, the reader will tell the staff to put a new one. So all these things are already happening. Smart shopping. Okay, shopping this is one scenario, which all of us are aware. We are already aware. Okay, how many steps have you walked today? Morning, I didn't go for walk today. You can easily make out this. Your watch itself tells you. Your mobile itself tells you. Okay, how well do I sleep? I think that again, if you have a Fitbit on your okay, I have a Fitbit, so it actually monitors whether I have slept for how many hours, whether the sleep quality was good or not, how many times I have woken up, okay, the last night, in the last 1 week, 1 month, okay, in the last 30 days, what was my sleeping pattern. So everything, whether you are awake, for how many minutes, how many time, how much time, you are restless, when did you have, deep sleep, etc., etc. All this, the sleeping pattern is already possible by just wearing a Fitbit, isn't it? So all of us know about this. All of us know about this. So I want to know more about myself, where you are going, who you are interacting with, how long you have spoken to friends, the affinity of connections. I think, this is quite possible. How much time you have spent on your WhatsApp is possible. You can actually see in your mobile, is it not? Possible. The tone of your messages also can be found out. The amount you text, tweet, or update is also possible. How much exercise you are getting, how much you get distracted. So all these things, are possible by just, this internet of things. So IoT will help us to know more about ourselves. So IoT helps you in life logging. You can log your life into the IoT system, is it not? If you want to know more about yourself, okay, you have to just give your okay, IoT device to do everything for you. Your mobile is able to do all of this now. Okay, fantastic, fantastic. I can't imagine more than this, what IoT can offer you. Okay, it will help you know more about yourself. Fantastic. So thought controlled computing. Okay, this is the latest, one can think of. So it's already produced. Okay, flagship product, which you call it as a mind wave. I think most of you must have heard of this. It's a headset, that can log into your computer using just your thoughts. Okay, just wear this on your head. Okay, mind wave headset. Okay, researchers recently used the easy headset to develop a toy car can be driven forward with thought. Okay, if you have a toy car, you think what has to happen to your car, it automatically happens. And there is something called NeuroSky's smart sensors can also track your heart rate and other bodily metrics and can be embedded in the next generation of wearable devices. Okay, so we make it possible for millions of consumers to capture and quantify critical health and wellness data. So this is the CEO of SoftBank. Okay, SoftBank CEO is Yang. He's the funder. SoftBank is the funder basically. So we make it possible for millions of consumers to capture and quantify critical health and wellness data. So thought-controlled computing is going to be a very big thing in the near future. Okay. So if you look at technological challenges of IoT, okay, so we know that one significant aspect in IoT is the large number of things being connected to the internet, each one providing a huge amount of data. Okay, finding ways to reliably store and interpret the masses of data through scalable applications remain a major technical challenge. So in one sentence, we can put everything. Okay, how to connect maximum number of things, how to make internet work more efficiently, how to reliably store the data and interpret that huge amount of data, massive data, okay, which is big data. Okay, how to scale your application. So that becomes a major technological challenge of IoT. Okay, so privacy becomes an issue, identity management, security and access control, standardization and interoperability. Okay, data deluge, all these become very, very important in IoT. Okay, so big data becomes very, very big like an elephant. So big data is not magic. It doesn't matter how much data you have if you can't make sense of it. Okay, so smart sensors have to communicate, talk to each other, connect to the cloud through gateway or router. Then the data generated by sensors can grow huge, maybe gigabits or terabits of data by doing video surveillance. So there will be big data issues. This is where scalability of clouds come in handy. So cloud is an IoT facilitator, not essential but very useful in practice. So cloud becomes a big IoT facilitator when you want to use IoT to its peak. So cloud and big data have become very, very important because of IoT explosion. Okay, so because of that there are several technologies which have there. So RFID has seen several improvements, okay, which will help you in logistic and supply chain management. And most of us work in WSN area, wireless sensor network area. We look at routing issues, low power devices for WSN sensors, okay, lifetime of sensor nodes, how it can be increased, how to look at the power constraint of your WSN node, how to increase the security of wireless sensor networks, how to do efficient routing. So all this, in fact, three of my research scholars, have did their PhD in WSN itself. Okay, manets. One guy worked on manets. So now, cloud of things, COT. So it actually overcomes the lack of software, memory, and hardware data processing capability through cloud computing. So if you ask any computer science student today, you'll only talking about cloud computing, nothing else. Okay, you'll be only talking about cloud computing, AI, and ML only, nothing else. In fact, we have introduced a BTech in AI and ML this year. Okay, the information technology BTech in IT has we had 120 seats in IT. We made 60 of them as AI and ML. Okay, BTech in AI and ML. Okay, so that's how this AI and ML are actually overtaking almost all kinds of applications. Okay, push intelligence into the devices. Okay, make machine learn by itself. So there are several issues in cloud of things, or COT as it is called. Okay, protocol support, energy efficiency, resource allocation, identity management, IPv6 deployment, location of data storage, security and privacy, unnecessary communication of data has to be avoided. So these are the various issues which people are looking at in cloud of things. I'm just telling you about how IoT technologies is actually driving a lot of research in computer science areas. So I was just talking about what are the research challenges Okay, research and development challenges in IoT. Okay, so I was talking about data deluge. What is data deluge? In fact, huge volumes of data that will be collected from connected devices. Okay, according to a rough estimate, more than 2.5 trillion bytes of new data every day will be logged by these systems. So we need layers of intelligence to transform this data into actionable information and insights. So analysis of data and its context will play a key role and poses significant challenges. So this data deluge is the one which is giving you big data issues, big data problems. Okay, so big data analytics has already taken by storm. So how to integrate with other systems? So IoT applications will integrate data from missions, ERP, enterprise resource planning, CRM systems, and social media in real time, allowing humans to intelligently interact with devices, devices with devices, and devices to back to humans. And this also provides us several integration issues. How to integrate yourself with different systems which are available becomes a big research and development area. One is the big data and the data deluge, and then how to integrate with different heterogeneous systems. Then security and privacy, I already told you, is very, very important. As more things get connected, cyber attacks becomes a major risk, and attacks could cause serious impact. As we expose more of our personal data to the IoT, and the cloud information privacy becomes a major concern, we need to incorporate appropriate security measures. So security and privacy, cyber security as well as network security, because we are using the internet. So network security also becomes important. So we can call it as information security. Basically, your information should be as secure as possible. So information security could be internet security or cyber security, or it could be network security as well. So connectivity also is a major issue. So reliable connectivity, that is the job of ENC engineers, including among gateways and the cloud at an affordable price, is the key to success of IoT. How to provide connectivity at very low price, that is and it should be reliable as well. Okay, so there is something called IOUT. IOUT is nothing but internet of underwater things. You don't have to be outside water. Okay, even under the ocean you can have internet of underwater things and underground things as well. So there is something called IOUT. That is the new research area. In fact, in our department we have a person who works in internet of underwater things. I think 2 PhDs are already out in this area, underwater things and underground things. Okay, so connectivity is a major challenge in R&D of IoT. We have to provide seamless connectivity and mobility scalability and performance assessment and interoperability. So these are the various issues in connectivity. In the management system, how to scalability, that is a capability in handling millions of things, is actually scalability. Object, device, and service management, easy to use location based management. Okay, then big data applications, I told you just now, information gathering, storage and analysis, and inference. So this becomes very, very important. So we may gather information, we may store information, we may analyze, but how to infer that? After analysis you have to do an inference. So inference becomes very, very important. So big data is a very interesting area. So applications, we have to develop several applications, we have to have new services and business models. Security, trust, and privacy to protect data becomes very, very important. So big data and their applications is really big in nature. So scalability of IoT and connectivity of IoT are all very, very important research and development areas. all is not well with IoT. People have lots of doubts. We always have pessimists in this world. Nobody is, all of us are not optimists. Okay, so most of us are pessimists. We always think things are not going to work. So several scholars and social observers and pessimists have doubts about the promises of the ubiquitous computing revolution in the areas of privacy. People say our we are exposing ourselves, so it's not a good thing. Security is a big issue. Autonomy and control, devices will start controlling you. You are no more yourself. Okay, you are controlled by some useless devices like your mobiles or computing systems. Social control will be out of control. So political manipulation can happen. You can see how elections can be won, by manipulating. Okay, so even the design, the environmental impact, influences on human moral decision making is the biggest controversy, which people are talking of IoT. Okay, moral values, ethics. So ethics will go to dogs. Ethical values of life, ethical values will go to dogs, is what many many pessimists are telling about. As engineers, we will continue to have ethical values in addition to improving IoT. So there will be influence on human moral decision making, and of course there will be health hazards. I think already people are talking of 5G hazard. Okay, US, many cities are not allowing. Okay, because they have implemented 5G in airports. Our Indian Indian aviation sector, has are not, landing in those cities where 5G has been implemented in their airports, because it is hazardous. Health hazard for the aircraft also. It can't land properly. Okay, because 5G devices are taken over there. It's a kind of IoT health hazard. Okay, so a lot of people are working in health hazards of 5G systems and IoT systems. Okay, so these are the areas, where there are a lot of criticisms and controversies. Okay, in summary, Internet of Things is just, we are seeing only the tip of the iceberg. It is only a tip of iceberg, but there is a lot of it inside. Okay, it is only the tip of an iceberg. Iceberg is so big actually. Okay, only the tip is being seen now. So IoT is still a tip of a iceberg. There is lot of things to be achieved. Okay, so what we need to do is we need to speed up the adaptation. So this is to do things, what we need to do. Okay, so we need to speed up the adaptation. That means all countries and companies must focus on innovation and invest in deploying the necessary sensors, improve cyber security. This is what all of us need to do. Okay, educate a new class of digital mechanical engineers. So we don't require, only electronics, ECE engineers, digital engineers, or CSE engineers. We also require good mechanical engineers, because we need to connect to things. Okay, we need education. Okay, a new class of digital mechanical engineers. We need to introduce, new areas of that's what people are doing right now. So the industrial internet can transform our industries and lives, pushing the boundaries of minds and missions, according to the GE report. Okay, so this is what industrial internet is going to do. Okay, so I have several references. If anybody are interested in looking at more data, they can look at all these references which are taken from, again, internet. Okay, I have something like 32 papers. Okay, from different areas, IEEE and other journals, and predominantly I have referred, Google. Okay, google.com, Wikipedia also I referred, Cisco white paper on Internet of Things. It's how the next evolution of the internet is changing everything by day. Very, very interesting. So GE Cloud Expo, Industrial Internet as a Service, very, very interesting. And MyMoose, this also is quite interesting. So I have referred, these 5 places, from the internet, and made my slides. So with this, I end my class, and I want to thank you. I have ended at 10:50 itself. I thought I'll keep the next few minutes for any questions which I have. Is that okay, madam?
Yes, sir.
I have covered,
Yes,
most
sir.
aspects of IoT. I am open
Yes,
to
sir.
questions now.
Yes, sir. We have some questions here in the
Yes,
chat
please.
box. So I'll just read out.
Yeah.
What is addressability? Of in the starting slides only, you have shown some 5 points in that addressability.
Yes, addressability basically means, because millions of things are getting attached to the IoT. The IPv4 and IPv6 128-bit addressing, can address up to 2 power 128 addresses only we can have, isn't it? Okay,
Yes,
that
sir.
means there is a
For IP.
limitation of IP addresses. IP addresses are
Yes.
not infinite. Okay, they are restricted to only 128 bits. Okay.
Correct.
So when things keep getting added, okay, because only 50 billion things are added as of now. Okay, when it becomes 100 billion or 200 billion, okay,
Mm.
how to have, okay, addressability issue becomes very important. So that naming system, the internet, whatever you are doing now, IP addresses, internet protocol, is not going to help us at all in IoT.
Yes, sir.
We have to have a different naming strategy. That is what
Correct.
is addressability. I hope I have answered this question. Next one, madam. I am not able to see the
Yes, sir. Yes,
chat
sir.
box here. I'll see the
Chat.
chat box myself.
Okay.
Yeah.
Okay.
Yeah. Yeah, no problem. Okay. What else?
Is there any sensor that can track REM sleep duration and time? By Shivaki
Oh,
sensor.
yeah. I think, Apple has come out with this REM sleep duration as well. I don't have that watch, Apple Watch. The latest Apple Watch, which costs several hundreds of dollars. I can't be. I think that is able to track, REM sleep. That's able to track REM. That's what I heard. I really do not know the answer for this. The Fitbit I have does not track, REM sleep. I understand. Yes. But the latest Apple Watch is able to track, REM sleep duration as well as time. I hope I have answered your question, Shiva Kishan. Any other questions, please?
Any other questions from the participants?
Oh, did I finish my talk early? I removed certain slides because, last time I couldn't finish many of them. I thought I'll restrict my slides. That's why I finished a bit early, I guess.
Sir, the questions are coming now. How the
Yeah.
smart cities project works on IoT? Smart
Oh,
cities project on IoT.
you have seen, these toll collecting places, toll. Okay,
Yes.
you are just, have a tag on your car. Okay, within seconds, you are out of the toll gate now. So that is part of IoT, is it
Fast
not?
tag. Fast tag. Yes.
Fast tag is a fantastic example of IoT. And in fact, you have what is called as VANETs, vehicular. What is VANET? Networks,
Vehicular mobile.
vehicular.
At,
A stands for what?
at,
I forgot. VANETs, vehicular networks, basically. Vehicular network, vehicle to vehicle connection, vehicle to. So all these, intelligent transport system, basically, ITS. ITS is a part of, it's a part of, the smart city. So smart city means, how best, you can route. In fact, you are already using, this, what is this called? To reach a place, we use, what is it called? Suppose I want to visit a place, it will, the road, whichever is having more number of vehicles, okay, that will be shown red, on your plot. What is that called, man? Maps, Google Maps. When you use Google Maps is an IoT application straight away. Okay, it will tell you in what time you are going to reach the destination. It tells you which route to take, which is a longer route, which is a shorter route. Okay, so within the city also this can happen. Okay, so smart city involves, smart grid, smart water management system, smart electricity management system. Okay, smart metering system. Okay, where the water is getting wasted, where the power is getting wasted. Okay, can you connect, solar power which you actually generate on your house. Okay, whether you can feed back the power back to the grid instead of, paying electric bills. The electricity provider is going to pay you back. Okay, all this is, part of the smart city. Okay, efficient road management system or intelligent transport system within a city, smart grid within the city, smart water monitoring system within the city. Okay, and there are so many things, which smart city will have. I hope I have answered your question, in a small way.
Yeah, yes, sir. Hi, good morning,
Yes.
Rajesh this side.
Yeah.
Yeah, I have asked this.
Have I answered your question? More or less?
So actually, these are the
Yeah.
concept I'm asking about the smart city project that is launched by our government. So I'm asking
Yeah.
in that respect, means
Yeah.
how they
Yeah.
are
Doing it.
implementing these things, because I have
Uh,
not seen anything like this in any city,
yeah. In
whatever you
Mangalore.
are saying.
Yeah. In Mangalore. Yeah. Mangalore, the roads have been widened. Okay. And for
Yes.
people, who want to walk, beautiful,
Hmm.
what are those called? Walkways. Okay. Cycle tracks have been made. Okay.
Okay.
Smart, what is that? Red light and all. What they're called? I'm unable to get them. Traffic management system. It has already come in Mangalore. Okay,
Okay. Okay.
beautifully. They actually find out, how many vehicles are going on a particular road, how to reroute them. Okay, it is all being done as a part of the smart city project. The bigger circles have been reduced to smaller ones with one red light tower, which has sensors, will be able to move your vehicles in a very smooth way. Okay,
Okay.
so congestion in Bangalore city is horrible. So unless Bangalore becomes a smart city, we can't cover. So in Bangalore, I can see water management. In fact, in NITK Surathkal itself, our students have designed an automatic water management system. Okay, so water was getting wasted in hostels. People leave the taps open. There are many students they don't bother. Okay, they keep the taps open and they keep the heaters on. So all this has been taken care within our campus itself. Our own ENC students plus some mechanical students joined together. They spent around 20 lakhs and we are able to save water in a very big way. So this is part of the smart city. Are you getting my point?
Okay.
So we have
Okay.
put
Okay.
several sensors, in pipes, okay, and they are connected to the internet. Even if I'm in Bangalore, I can check, how much water is flowing in which pipe, where the water is getting wasted, how any repair is required in any water pipeline system, either in residential quarters of NITK Surathkal or in the hostel area, okay, or in the academic section, So all water management system has already been done within our own campus. Okay, so smart
Okay. Okay, sir.
city is a reality, and the government has spent a lot of money on that. But our people, are so corrupt. If 10 lakh, I mean, if 100 lakhs is assigned to them, they spent only 40, 50 lakhs, and 50 lakhs they eat off. So that's why you
Okay.
don't
Okay, sir.
see a smart city happening in a big way, unless
Okay.
corruption is removed in our country. You may not be able to see a smart city at all.
Yes, sir.
Okay.
Actually, visible impact is not in the place.
It is not
That's
in
why.
place because of corrupt practices, which we have imbibed in our culture. Okay, but in Mangalore, I can see several roads being widened, and the congestion of vehicles has been controlled. People are able to cycle around within the city, and I can see a lot of things happening within Mangalore city and within our campus at least.
Okay, sir. Thank you.
Yeah. Oh, VANET is vehicular ad hoc networks. Okay, I had forgotten about VANETs are basically vehicular ad hoc networks. I think Suman Paul has helped me out in this. Vehicular ad hoc networks, VANETs. In fact, one of my students is working on VANETs. Okay, we are trying to connect the vehicular ad hoc networks to SDN, software defined network. One of my PhD student is working on SDN, software defined networks, trying to integrate with the VANETs. So VANET, okay, being managed by a software defined network. So I'm sorry, I just forgot, ad hoc word, in vehicular networks. Any other question? I'm not able to see.
Sir, what are the quality of service parameters in IoT?
That is decided by how happy a person is. Okay, do the things work correctly or not? You put on the AC when you are just having tea in your house. Your car is in the outside. Actually, you want to put on the AC of your car. Okay, and you finish your chai and breakfast and come to the car and you see that the AC has not turned on at all. Okay, that is bad. When you come near the vehicle, the vehicle doesn't open. So that is the failure. the quality of service parameter is basically the happiness quotient of a person using IoT services. In simple terms, which I'm trying to tell you. And somebody was saying it is not visible, that a smart city is not visible. When they become visible, that becomes the quality of service parameter. Okay, the happiness of the person, who was talking about smart city. I don't see any smart city in our country, but I could see in Mangalore, in many places, and within our own campus. So quality of service parameter is all about, okay, how well you are connected, reliability of the internet, okay, reliability of the internet, reliability of the sensors, security of the sensors, okay, and how cheap the services are, okay. In fact, I can go on and on talking about QoS parameters, okay. In one word, I can say the happiness of the person, using IoT services. Have I answered the question?
Yes, sir. Yes, sir.
Sir.
Mohit, yes, sir.
Okay. Yes. Anybody
Sir,
else?
one more question is there. What
Mhm.
is the impact of IoT in aeronautical and aerospace?
Oh, I told you the impact already. Our Indian aeronautical industry, our aircrafts, decided not to land in US airports, 5 cities in US airports, because 5G network was in place there. 5G implementation within the airport, which is basically an IoT. Okay, the aircraft, has several avionic systems, is it not? Aviation electronic systems, which fail due to 5G. Okay, they collect a lot of data about your landing time. Okay, how many people are there within the aircraft, which landing space is available for that. Everything is being controlled by 5G network in 5 cities of US. And our people not happy because our system are going to fail. You may not land in the proper this thing at all. So there is a possibility, in fact, in a big way, IoT will be useful in aeronautical industry, aviation industry. In fact, it can avoid accidents, but actually, we are fearing accident because of 5G network. That's what is the criticism all about IoT. In case they don't perform properly, it could be a hazardous thing. But in the aviation sector, it's going to be used in a very, very big way. Within the aircraft, between the aircrafts, and airports, within the airports, in aviation sector, it's going to be a very big thing. The industrial internet, what we are talking, will become very big in aviation industry in particular. Okay, IoT is going to affect in a very big way the aviation industry. Out of the 40%, at least 15% will be taken by it. That is my gut feeling. Hope I have answered. I don't know. I had
Yes,
been
sir.
very generic in this. Yeah. I saw some Rajesh Lohani asking, how can ITC student work with physical sensory devices as they are more indulged with software part, not much exposed with physical devices? Oh, very true. IT and CS engineers are useless because they don't understand physical things. They only understand, the software part. That is why, okay, we need more engineers from electronics doing CS, more mechanical people doing, masters in CS and PhDs in CS. So CS will be there in every area. Okay, he is very right, Rajesh Rohani. I really appreciate you. They don't understand, physical sensory devices. They don't know sensors. They don't know embedded systems. They don't know embedded software too. Forget about the embedded hardware. Okay, it's we, the electronics and communication engineers, to educate these CS fellows. Tell them how our sensors work, how our internet works. In fact, they don't know about internet also. They only are in the application layer, or at the most, just the application layer. I feel from the network layer down, they are useless. Only in the top layer, they operate. You are very correct. Okay, IT and CS students and teachers are more indulged with software only. Those fellows will not be useful at all in IoT unless they understand, the physical world. The physical world has to be understood by them. You are very right. All of us have to integrate. All of us have to integrate. Okay, so interdisciplinary is the answer for your question. We need to become interdisciplinary. In fact, E&C people have. We are having very good knowledge about the application layer as well as the physical layer. So that is where CS people fail, IT and CS people. Hope I have answered, Rajesh.
Yes, sir. Actually, one more question regarding to that. The
Yeah.
problem is that IoT introduced in our curriculum last year, and
Yeah.
they have introduced the subject only and the theoretical part.
Yeah.
And apart from that, in lab part, they have introduced Python and Arduino.
Yeah, that's good. I think that is how you should start. That's a very good thing. If you can work with Arduino boards and make your lab, IoT lab. You should have IoT lab. In fact, we have a wireless sensor network lab. I'm in charge of that Center of Excellence in Wireless Sensor Networks. We still haven't bought several sensors. Still, IoT, people are using Arduino boards and developing things using Python and all. But then, a lot of work needs to be done. You are right. I think we should not only talk of theory. We should actually do things. So IoT is all about doing things. Yeah, I
Yes, sir.
think
Actually, practical is very less in our curriculum, so that's why.
Yeah, lacking. I think IoT should be taught in lab. It should be some kind of 202. That means 2 hours of theory and 2 hours of lab, rather than 4 hours of theory. Okay, 2 hours you should spend in lab. Okay, you should at least connect all the things within the lab. Have RFID tags. Okay, attendance system. Somebody is saying share the attendance link. Okay, this attendance should be automatic. The moment you come and sit in the class, automatically the attendance should be taken. The teacher should not be reading out names or taking attendance for 10 to 15 minutes. That itself is not happening, isn't it?
Right.
So a lot needs to be done. You are very correct. You are very correct, Rajesh.
Thank you.
So any other questions? I think my system says 2 hours, 8 minutes now. I started a bit early because you started late. Any questions, madam?
No questions here, sir. Thank you very much.
So with this, I end my lecture. Thank you very much
Yeah.
for giving me an opportunity to speak out.
Thank you, sir. Thank you
I
so
didn't
much.
go deep. I should have taken one particular topic and gone deeper, but I couldn't do it. That's what I have been doing, but that is not a smart method. Okay. Attendance link, just copy and paste the link in your browser is not a smart method. Very true. Yeah, we need to do a lot in IoT. Let us do and hope things become possible. Thank you very much, madam. Thank you, Professor
Thank
Prasanna.
you, sir.
Thank you, sir. Thank you very much.
Thank you, madam. I hope it was interesting.
Yeah, very
Yes, sir.
much.
Yes.
Thank you.
Thank
Thank you.
Quite interesting.
Thank you so much. Thank you
Just
so
a
much.
minute, sir. Just a minute. Sir, madam.
Yes, sir.
Please continue.
Sir, thank you so much, sir. Prasanna Kumar, sir, also, I want to thank him very much because he has arranged this session by Dr. Professor Muralidhar Kulkarni, sir. So thank you very much.
Thank you so much. Thank you. Thank you. Hope it was interesting. I didn't bore
yes, sir.
anyone
Yes,
of you.
sir. No, sir, not at all.
Prasanna is keeping quiet. That means he's not happy.
No, I would like to conclude, madam.
Yeah,
Shall I continue,
please.
ma'am?
Yes, sir. Yes, sir. Sure.
Yeah. It's really. I convey thanks to all distinguished participants for attending this AICTE Training and Learning ATAL sponsored 5-day online faculty development program on Industry 4.0 on the third day first session. I am profusely thankful to our beloved speaker, Professor Dr. M. Muralidhar Kulkarni, for the wonderful, exciting, throughout his expert lecture for more than 2 hours in this morning. Truly, it helps us in enhancing and enriching knowledge in the field of internet. Thank you very much, sir. Thank you so much. We are totally satisfied. Okay.
Thank you.
Really,
Thank you.
you enhanced our
Thank you,
skills.
Prasanna.
Okay. Thank you very much for
Thank you,
accepting our
Bharati
invitation.
Gururaj.
Okay.
I think you are quite
Thank you,
happy.
sir.
I
Thank you
could
very
see
much.
your.
Thank you.
Thank you,
Yes,
madam.
sir.
Thank you so much.
We are quite happy.
No, sir, I'm very much, no, information theory and coding, I was started taking from long back, around 10 to 15 times I have handled. So when your book came, I just started,
How is it,
I
madam?
was
It's a
referred.
good book? It's a good book.
Yes,
Yes.
sir. Yes, sir.
Okay, please
Okay.
refer to your students as well.
Yes,
Maximum
sir.
people
Yes,
should
sir.
get benefited. We are
Yes, sir.
modifying the book. We're adding some more things to it very soon. Okay.
Okay.
Advanced topics are missing, so we are going to
Oh,
add it
yes, sir.
very soon. Thank you, madam.
Oh,
Thank you so much for
thank you,
all
sir.
your doing this. Thank you.
Thank you, sir.
Thank you, Prasanna. Thank you, Bharati Gurraj.
Thank you.
Thank you so much.
Thank you,
Thank you.
sir.
Yeah, thank you, sir.
Thank you. Thank you.
Okay, bye, sir.
Bye.
Bye.
Dear participants, now we will have a break for 10 minutes. So we'll start the session at sir ಎಷ್ಟೊತ್ತಿಗೆ ಶುರು ಮಾಡೋಣ ಪ್ರಸನ್ನ sir
11:15. He's there already. The next speaker.
He's there already. The speaker is there already. So we'll take a short break for 5 to 10 minutes. So we'll join to the session. Sir is already there. So kindly join in time, participants. Thank you.
We need to exit or we need to continue with the same session?
Same session.
Sir, no need
Same
to
session.
exit, sir. Be in the same
Same link.
Same link only.
Same session. Yeah.
Thank you, sir.